Hey, how you doing? And welcome to the last Teach It. I am super excited to talk about this one. We're going to be talking about college students and the frequency at which they work out. So let's get right to it. Our main question here first is, do college students work out more than the average person? So we're going to use a chi-square goodness of fit test to be able to calculate that. We're going to take the groups first. We're going to break them down into our subcategories. For this one, we have no exercise, one time a week, or two or more times a week. With our observed scores, we have 15, 19, and 6. And then we have our expected scores. So what these expected scores are going to be is basically a normalization or generalization of these numbers. So obviously, there are not going to be 30, 40 people working out 2 or more times a week and 0 that only work out once. So we have to balance these numbers. So that's what I did right here. Then the next step is we're going to take the difference of each of the two. So 15 minus 13 is 2. 19 minus 14 is 5, and so on and so forth. We need to make sure that this column is equal to 0. If it's not equal to 0, that means that we've done something wrong, and we need to go back and readdress the previous parts. As we can tell, 5 plus 2 plus negative 7 is 0. We're going to take the difference of the squares right here. So we're going to square each one. So that's going to be 2 squared, 5 squared, 7 squared. And obviously, don't forget that this negative 7 is going to be in parentheses when you square it, so it'll come out positive. Then we're going to take these and finally divide them by e. So we have 4, 14. And it's important that you take the largest number of these expected values. So we have 4, 14, 25 of 14, and 49 of 14. And then we're moving on to step 5 right here. Step 5 is going to be adding up all of the steps that we just did right here. So we're going to take the x squared, which is our critical value, 4 divided by 14, plus 25 divided by 14, plus 49 divided by 14, which gives us 5.57. And that's important, but we're going to keep on moving forward. Then we're going to take the degrees of freedom. So we have 3 separate ones right here. And it's going to be 3 minus 1, which is 2. Our critical value is going to be 0.05. We're going to take the degrees of freedom, which is 2, and that gives us our critical value, which is in the back of the book in the appendix for a chi-squared score, which is going to be 5.99. This 5.57 is less than 5.99, so therefore our observed expectancy of college students who work out is smaller than our expected frequency. Therefore, we will fail to reject the null hypothesis. So this is true so far. So we're going to move on over. I'm going to slide you guys up and around. And that way you guys can have a good look at this last one. So this is really important. This is where we're going to take our general information. We're going to take 40% of college students who work out because those were the numbers that I did when I did my research. And it says that 40% of college students work out. So that means that the other 60% do not. So we took these of the students who work out at least once and the students who don't work out at least once. So we're going to take the original scores back from what we just did. So we're going to take that 5.57 from over here. We're going to bring it right over here. Since we can't have half people, there's no such thing as half of a person, we're going to round this up to 6. So that's what gives us these scores. That's going to give us those over there. We're going to take these and we're going to add them together. So that's what this is right here. We're taking the original or the observed from the expected and we're going to subtract them, square them, and then we're going to divide it by the same number of the e, which is our expected. We're going to add these together. They gave us 11.2912. And when you do that, and you check the significance level. This is the most important part, is when we check these significance levels to see what it means for our scores. At 0.01 significance level and a D of F of only equaling 1, our critical value is going to be 6.63, which means obviously 11.2912 is a lot larger than that. This means that we are going to fail to reject the null hypothesis.